Okay, in today's video, we are going to go over kinetic energy. And here we have our definition of kinetic energy. Now, an object that is in motion, and that's what kinetic means, in motion. An object that is in motion has the ability to do work. That is, it has the ability to apply a force over a distance, and therefore we say it has energy. The energy that an object possesses, that an object has due to their motion, is called kinetic energy. And that's often how we just simplify the definition. We often say the definition of kinetic energy is the energy of motion. Okay? Something has to be moving to have kinetic energy. Now, this is the equation we use for kinetic energy. To calculate kinetic energy, Ke is equal to 1/2 mv squared. M stands for the mass. V stands for the velocity, and you're going to square the velocity and only the velocity. So it's 1/2 times the mass times the velocity squared. It doesn't matter in what order you put those three terms into your calculator because it's all multiplication, but you have to square just the velocity, 1/2 mv squared. And when we do that, we get joules. The answer that you're going to get, the units are going to be in joules because joules is the units for energy and work. Now, let's look at the relationship between the mass and the kinetic energy and then the velocity and the kinetic energy. And we can see that the mass is directly proportional, that the kinetic energy is directly proportional to the mass. Now, what do we mean when we say it's directly proportional? And that means if we double the mass, or in any case we increase the mass, then the kinetic energy will also double. If we decrease the mass, then the kinetic energy is going to decrease. So when we say directly proportional, we mean that as one thing increases, like the mass, then the other thing is also going to increase, like the kinetic energy. So mass increases, kinetic energy increases. Mass decreases, kinetic energy decreases. Now, one of the most interesting things about the kinetic energy is its relationship to the velocity, or to the velocity squared, because it is squared, and therefore we say that the kinetic energy is directly proportional to the square of the speed or the square of the velocity. And I'm going to try and show you what we mean by that because it is significant. Now, what we have here is we have 4 different velocities. This is going to be kind of our ground velocity. Okay, this is going to be our base velocity, 5 meters per second. That is going to be our base that we're going to use. And then we're going to compare the other 3 to that, the kinetic energy the object has when it's going 5 meters per second. Then when we double the velocity, because 10 is obviously double 5, we're going to triple the velocity. Triple 5 is 15, and then we're going to quadruple it, and we're going to get 20 meters per second. Okay, now we're going to calculate the kinetic energy. Now, I didn't give you a mass, and when I like to do these problems, I like to just choose some nice round number because it doesn't really matter what mass we use. You could use 1 kilogram, 10 kilograms, 100. You could use 348.62, but it's a little easier just to pick a nice round number so that we can see the relationship to the velocity and the kinetic energy, and I believe I chose 100 kilograms. So we said Ke is 1/2 mv squared. That means the Ke in this case is 1/2 0.5, same thing as 1/2, right? Times 100 kilograms times 5 squared, which of course is 25. So 25 times 100 is 2,500, and half of that is 1,250. So an object that has the mass of 100 kilograms and it's going 5 meters per second will have 1,250 joules of kinetic energy. Now we're going to double the velocity to 10. And what is going to happen to the kinetic energy because it's mv squared? So let's see. Now we're going to double. We still have 10 here. We're going to double, we double the velocity to 10. We're going to square that. So 10 times 100 times 1/2 is going to be 5,000. And that shows you that when you double the velocity, and because the kinetic energy is directly proportional to the square of that velocity, you'll notice the velocity goes up by a factor of 4. Okay, now we're going to triple it and do the same thing, and we see that it goes up to, the kinetic energy increases when we triple the velocity to 11,250, which means you might notice that is 9 times, and if it's 4, then you should notice it's going to be 16 times higher. Okay, so you'll notice it's the square of the velocity. So if we double the velocity, you square it, you get 4 at 4 times. You square this, you get 9. You square this, you get 16. Now this is significant when you're driving a car. It has practical applications because it means every time you double your speed, okay, when you double your speed, that means it's going to take you 4 times as long or 4 times the distance to stop, because the brakes, the friction with the road has to do 4 times as much energy. And then this means it's going to be 9 times as long, and this means it's going to take you 16 times the distance to stop if you're going 20 meters per second, which is 4 times more than 5 meters per second. Okay, so that shows you the relationship between the square of the velocity and the kinetic energy. Okay, so that's all we're going to do for right now for kinetic energy. In the next video, which you can click and link to right here, you can see some examples that we're going to do, and we're going to use kinetic energy and the work energy theorem to solve some problems. So thank you very much for watching. I hope you found that helpful. If you did, please give me a nice positive comment in the comment section below, and give me a nice thumbs up down there also. Okay, thanks for watching, and we'll see you in the next video.